Hi all, welcome to microbiology lectures. Today I'm going to talk a little bit about statistical analysis, just so I can precursor this a little bit. Remember that in this course you need to do statistics each week to analyze the data that we collect in lab. A couple things about that. I realize that in many cases you might be violating the assumptions of these different statistical analysis tests because your sample size is not high enough, or you're not testing for correlations between factors and things like that. This is really just to get you started to analyze data. Okay, and so the first one I want to talk about is linear regression. Okay, so many of you probably know how to do this already, but I'm in Excel and I have 3 different data sets here, and I'm going to go through each example. Remember, I told you you could do a linear regression, a chi-square test for goodness of fit, or a student t-test. Okay? So let's start with the linear regression. Let's say we have temperature here in degrees Celsius, and bacteria colonies, or number of bacteria colonies. And maybe by looking at the data originally, you're like, wow, it looks like as the temperature goes up, so does the number of colonies of bacteria. Okay? So to get at that you would, if that's your analysis, originally looking at the data, you might say, well, I think there's probably a relationship. There's a linear relationship between these two objects. So let's go ahead and test to see if there is. So the first thing you can do is click on these 2 columns, highlight them, and then if you go over to insert, since a linear regression is based on plotting the data, the x and y data, we're going to choose to plot it in a scatter plot. So there you can see it plotted a graph of all the points. Okay, just for convenience to me, just because I don't like the look of empty space, I'm going to go in and I'm going to format the chart area. Okay, maybe I'm going to, let's format the axis, I'm sorry, not the chart area. And instead of being at minimum of 0, let's say a minimum of 15, and then I should be able to switch that over, and there you can see it shifted the graph a little bit. Everything else looks good to me. If you were to turn this in, you would want x-axis, y-axis, so you want to label the x-axis as temperature in Celsius and the y-axis as number of colonies. But if you don't know how to do that, we can get into that later. But right now we're going to do a statistical analysis. So if I click on one of the points, right click on one of the points, it brings me up these options, and if I say I want to add a trend line, I'm going to add a trend line to the data set. Okay, so it's going to draw a linear line through as many points as possible. That's the best fit line for this data. Okay, I can come over here if I think it's a logarithmic data, if it's polynomial, all kinds of things, but because this is a linear regression, we want a linear line. Okay, and then we can just tell Excel to give us a little bit more information. We could tell it to display the equation on the chart. This might be important if we're going to try to predict variables from the data that we have. And more importantly, at least from a data analysis point, is we're going to display the r squared. So here you can drag these up. Okay, there you can see that's the line equation, and that's the r squared. The r squared is 0.84 for this data set. Anything that's really above about 0.7 is a pretty good fit. The closer you are to 1, the better these values are fit to that line, thus indicating the correlation between the 2 variables, at least based on the data that we've collected. Okay, so that's linear regression. Alright, I'm going to go ahead and delete that, and now we're going to go into chi-square real quick. Okay, we did one of these examples in class. You can do it by hand with, here I'm just saying that we have selective medium or media that we're growing organisms on. We might have an expected variable where there's no difference. We think that every media is going to grow about 50 organisms, and that would be our expected value. And then we might come out and actually use the observed data to then compare. You can do it by hand, or because you're in Excel, I like to just create an equation, okay, a function. So to do that, you hit equals, and then I'm going to open two parentheses. And remember, chi-squared is observed minus expected squared. So we're going to take that observed value minus the expected value. Okay, close the parentheses, and then that's raised or squared. Okay, and then we can close the parentheses again, and it's divided by the expected value. Okay, so observed minus expected squared divided by expected. If we hit enter, that gives us the value for the chi-square for this media. But remember, chi-square is the sum of all the chi-squared values. The cool thing about Excel, if you are not aware of this, is if you click on this little teeny box right here, or square, and you drag it down, it will make that equation for each one of the boxes below. So in this case, this is saying, okay, if you look up here, it's saying F4, which is this value here, this observed, minus E4, that expected, times 2 and divided by that expected. So it just creates it all. And then we can go to the bottom here, create another function, go equal sum. Okay, and we want to sum these products together. So I just open the parentheses, highlight all the things I want to add together, close it off, hit enter, and there's my total chi-square value. Remember, we're interested in degree of freedom, and so in this case, n minus 1, we have 10 different subjects. Minus 1, 9. So if we go to the table, there's 9. And if we go over to 0.05, that's our alpha that we're interested in. It's the value there is 16.919. If our value is bigger than that, it's saying that the two things that we are comparing are statistically different from each other, and our value is bigger than 16.919. Okay, and then you can conclude other things from this data set. You might say, well, if these are all different types of media, you might say, well, maybe the media of A3, A6, and A9 is driving the significance. And those media seem to either allow for more growth or decrease growth of the bacteria. Okay, pretty simple, but that's how you would do a chi-square in Excel. Okay. Now, student t-test, a little bit more difficult to create or generate by hand, so I don't suggest doing it by hand. There's lots of steps. If you want all those steps and do it by hand, come see me and I can give you examples of how to do that. Instead, why don't we just allow Excel to do it for us, but give it some parameters that we know. Okay, so in order to do that, most of you are not going to have the data analysis package like loaded up in your Excel. To load this up, you just go to File, go down to Options, okay, and go to Add-ins, and then right here there's, well, I have mine loaded, so right here you would see Analysis Tool Pack. You can click on that, and then it says manage your Excel add-ins, and you'd hit go, and then this is not going to be clicked if you don't see it on your toolbar. So you can click on it and then hit OK, and then it will pop up underneath your data toolbar. Okay, and then if you go to data analysis, you can look at all the different analysis packages that Excel has. So you can run an ANOVA. Typically you do that if you have 3 or more categories. If you have two categories like I do here, you can run a t-test. For this data set, I don't have any prior knowledge, and often you won't have any prior knowledge of which direction you might expect things to go. You might hope an antibiotic has a negative effect on a bacteria, but sometimes they might actually have a positive effect. It might actually cause more growth because maybe that bacteria can use the nutrients from that antibiotic or break that antibiotic down and utilize it for energy. So you don't really know. So often you'll want to run what we call a paired two-sample t-test, or you're sampling both edges. It could be positive relationship, it could be a negative relationship. You don't know. You don't have prior knowledge. So if I click on that, then I go and select the data that I'm interested in. So I select this column first, and then I can come by and select this column. And because you don't have any prior knowledge, you don't need to worry about hypothesizing a difference that you might expect. Alpha level should stay at 0.05. This is default in Excel typically, and that's the default that biologists use, is a 95% confidence interval. The output range, so you could do this on a new worksheet if you want, or a new workbook, but I prefer to just put it next to whatever I'm looking at. So I select output range, and then just select a spot on the sheet that I want it to put it, and then I hit OK. Okay, so the first thing it does is it tells me the mean of both these columns. The first column was 89 or 49.3, and the second one 26.4. The variation between the columns, how many observations, a correlation factor, which if you don't know what this is basically like your linear regression. How correlated are these two columns to each other? Okay, and that's not a very high correlation. Hypothesis, we didn't put one in. Degrees of freedom calculated for you. There's 9. Okay, and then it gives you two statistical analysis. It gives you a one tail, that t-stat for that, so one direction, and you can see here the p-value is 0.0005. Okay, remember, if it's anything less than 0.05, then it's significant. So in this case, the relationship between these two, they are very significantly different from each other. Okay, and then this is a two-tail, so this is both forward and reverse, and you can see there the p-value is not quite as significant as this one, but in any rate, it's still highly significant that no matter what direction we look, positive or negative, these two columns are significantly different from each other. Okay, and we'll talk a lot more about statistics and what does it mean, but for now I just wanted to get that out there and show you guys how to do some just easy statistics with some data sets that you guys are going to collect. Till next time.